All right, in this video, we're going to talk about section 3D, which is index numbers. Mainly, we'll talk about the CPI or the Consumer Price Index and beyond. Index numbers are common because they provide a simple way to compare measurements at different times or in different places. So here in this section, we're going to investigate the meaning and use of index numbers, focusing especially on the Consumer Price Index, or CPI for short. And pretty much you've probably heard that phrase used in news media concerning about this Consumer Price Index and how that affects us in real life, what we buy, and so on. Now, what is an index number? An index number provides a simple way to compare measurements at different times or in different places. The value of one particular time or place must be chosen as the reference value. And to calculate the index number, we take the value, divide that by the reference value, multiplied by 100. Now, keep in mind that there is no particular rule for rounding index numbers, but in this video, for these examples, or for most of these examples, we'll round them to the nearest tenth, unless absolutely indicated in the particular problem. So starting with this first example, let's say, suppose the current cost of gasoline is $2.64 per gallon. Find the current price index number using the 1975 price of 56.7 cents as the reference value. And here's what I'm going to do. In this case, the $2.64, I'm going to write that in cents because I know $1 is 100 cents. So $2.64 will be just 264 cents. 264 cents. Okay, and I'm going to use this formula at the very top to calculate the index number. That's going to give me the current price index number. So my index number that I'm dealing with is this. The value, which is 264 cents, that would be divided by the 1975 price of 56.7 cents. That's being used as the reference value. And then times 100. Let's say I want to round this off to one decimal place. So, okay. In this case here, I'm going to clear this out. Let's see, 264 divided by 56.7 times 100. All right, to one decimal place, this will be 465.6. That would be my index number, 465.6. Using the 1975 price of 56.7 cents as a reference value. That would be the current price index number if the current price of gasoline was $2.64 per gallon. All right, now let's look at making comparisons with index numbers. The primary purpose of index numbers is to facilitate comparison. We can also make comparisons when neither value is the reference value. Like in this example, if it costs $9 to fill a gas tank in 1980, how much will it cost? How much will it have to cost to fill the same tank in 1990? Okay, now let's look at the cost of gas that was in 1980. Using this table here in 1980, the cost to fill one tank of gas, or the cost was $1.22 per gallon. And we have $9 to fill a gas tank in 1980. So I will take that $9 and divide that by the price per gallon, which is $1.22 per 1 gallon. I'm using unit analysis in this case, so that way you can see how I'm going to solve this problem. And of course, when you multiply fractions, when you divide fractions, you multiply by the reciprocal here. I'm just going to flip this fraction as 1 gallon per $1.22. You're going to see the dollar signs divide out. So it's going to be 9 divided by 1.22. So 9 divided by 1.22, or 9 divided by $1.22. I'm going to round this off to 3 decimal places. That way I can get a more precise answer, 7.377. So it's going to be like 7.377 gallons of gasoline. Okay. Back in 1980, for $9, I can fill the tank up with 7.377 gallons. Okay, so now, how much will it have cost to fill this same tank in 1990? Let's look at the cost in 1990, which was $1.23. So we got 7.377 gallons. So I'm going to say the cost in 1990 is this 7.377 gallons of gas times, in 1990 is $1.23 per 1 gallon. So in this case here, the gallons divide out, and I'll multiply 7.377. I've already had that here, times $1.23. Now, since we're dealing with money amounts, we're going to round to 2 decimal places. So this will be 9.07. So in other words, it's going to take $9.77 to fill that same tank of gas in 1990. Okay. All right, on the next page, let's say if we wanted to know how much of the same tank of gas can be filled using the same amount from 1 year to another, we divide the index numbers for the 2 years. So in example 3, if it cost $15 to fill a gas tank in 2000, how much of the same tank could be filled with $15 in 2010? All right, so in this case here, we need to consider this, the price index in 2000. That has to be divided by the price index in 2010. So in 2000, we look at the price index, which is this last column here. So in 2000, that price index was 127.9. That's going to be divided by the price index in 2010. Here is 232.8. And we're going to round the final answer to 2 decimal places. So 127.9 divided by 232.8. To 2 decimal places, this will be 0.5. 0.55. Okay. So it's going to be 0.55 of the same tank of gas that could be filled with $15 in 2010. And we'll leave this as a decimal. Okay. All right. Now let's look at the consumer price index, which is what we will be talking about pretty much with these examples that we're going to do here. All right. Inflation is a substantial increase in price over time. Okay. You've been hearing about what inflation is on the TV news and how it can impact us on things that we buy, things like clothing, also on food, gasoline. Of course, we've seen that happen. And then on the opposite side, we have deflation. That occurs when prices and wages occasionally decline over time. Okay. Now the consumer price index, or CPI, is going to be based on an average of prices for a sample of more than 60,000 goods, services, and housing costs. It is computed and reported monthly. The CPI allows us to compare overall prices at different times. Okay. So for this video and for this particular lesson, here's our table of the average annual consumer price index from 1973 up to 2005. Okay, and they're using 1982 to 1984 to equal 100. Because if you look at 1982, 1983, and 1984, pretty much if you take the average of those CPIs, that's going to be approximately 100. Okay. And also in the examples that we'll be doing here, you're going to see you'll have that table to refer to. Okay. Now, here we're going to be adjusting prices for inflation. We're going to talk about that. Because prices of most commodities tend to rise over time, we can't compare prices fairly unless we take into account the increase we would have expected from inflation. Okay, so if we were given a price in dollars for year X and the equivalent price in dollars for year Y is going to be this. The price in dollars for year Y will be equal to the price in dollars for year X multiplied by the consumer price index for Y divided by the consumer price index for X, where X and Y represent the years. Okay, we're going to be using that to help us find out the cost based on consumer price indices. Like in this example, suppose you needed $15,000 to maintain a particular standard of living in 1976. How much would you have needed in 1997 to maintain the same standard of living? Assume that all prices have risen at the same rate as the consumer price index, or CPI. So here's the table that we're going to be referring to. Now we're going to pretty much identify some things here. And also we're going to use this formula at the very top. All right, so our X in this case will be 1976. That's going to be the beginning. And then the Y will be the year 1997. Keep in mind, X and Y are years. And also, we need to find out something else. We needed $15,000 to maintain a particular standard of living in 1976. That would be our price in dollars for X, which is 1976. And that was $15,000. Now we need to find the consumer price index for year X, which was in 1976. If you look at your table for 1976, that consumer price index was 56.9. Now for the consumer price index for Y, which was 1997, go to 1997 and you find that the consumer price index was 160.5. Okay. So now we're trying to find the price in the year 1997. So that means how much will we need to maintain that same standard of living in 1997? All right, so that's where we use this formula up here, and I will rewrite that, the price in dollars for Y, which is 1997. That would equal to the price in dollars for X, which is 1976, times the consumer price index for Y, divided by the consumer price index for X. Now let's do some substitution here. The price in dollars for year X, 1976, that was $15,000, multiplied by the consumer price index for Y, which was 160.5, divided by the consumer price index for X, that was 56.9. Okay. Now here we're going to round to the nearest dollar. So that means I'm going to do 15,000 times 160.5 divided by 56.9. So to the nearest dollar, it will be 42,311. So what that means here is this: for us to maintain the same standard of living that we had back in 1976, we would have to have $42,311 in 1997. Okay, so that's how we calculate this particular problem, finding out how much will we need. Okay, and we'll do more of these shortly. But let me go ahead and discuss what the rate of inflation is from one year to the next. That's going to be usually defined as the relative change in the consumer price index. So here the rate of inflation can be calculated by using this formula. The inflation rate or rate of inflation would be the consumer price index for Y minus the consumer price index for X divided by the consumer price index for X times 100. X and Y are going to be years. Okay. So on the next page, this example, number 5, is like that. Find the inflation rate from 1997 to 1998. Assume that all prices have risen at the same rate as the CPI. Okay, so the CPI for X, that's going to represent 1997. And by the way, X is going to be 1997. and Y will be 1998. So the consumer price index for X, which is 1997, let's find 1997, here it is. That's the 160.5. And then our consumer price index, or CPI, for Y, and Y is 1998. So the consumer price index for 1998 is 163.0. All right, so now the way we're going to find the inflation rate is this. That's going to be equal to the consumer price index for Y minus the consumer price index for X divided by the consumer price index for X times 100%. Now let's do some substitution. The consumer price index for Y is 163.0 minus the consumer price index for X, that was 160.5, divided by the consumer price index for X, that's 2, again, 160.5. And then we're going to multiply by 100%. Let's see, if I subtract 160.5 from 163, I would get 2.5. Divide that by the 160.5 times 100%. Okay. So if I do 2.5 divided by 160.5 times 100, this will be 2.5 divided by 160.5 times 100. Sometimes I can be typing the wrong thing. Here we go. So one decimal place, this will be approximately 1.6. So the inflation rate from 1997 to 1998 is 1.6%. 1.6%. Okay. All right, now let's take a look at example 6 here. Suppose you needed 28 cents to buy a particular box of macaroni and cheese in 1977. How much will it cost to buy the same box of macaroni and cheese in 2003? And we're to assume that all prices have risen at the same rate as the CPI. Okay, now let's identify this. Let's see, we're starting with 1977, that would be X. I'm sorry, 1977. And Y would be 2003. So the price in dollars for X was 28 cents. The CPI for X, the consumer price index, X is 1977, so the consumer price index there was 60.6. And then your consumer price index for Y, and Y was 2003, way over here, 184.0. Okay. So now the price in dollars for Y, and that was 2003, by the way, that's going to be equal to the price in X in dollars for X, which was, by the way, 1977 times the consumer price index for Y divided by the consumer price index for X. Now, the consumer price index for X in 1977 was 28 cents times the consumer price index for Y was 184, and that represented 2003, divided by the consumer price index for X, which represented 1977, 60.6. So in this case here, 0.28 times 184.0 divided by 60.6. To two decimal places, that price for in 2003 would be 85 cents or 0.85. So in other words, the cost to buy the same box of macaroni and cheese in 2003 would be 85 cents. Okay. All right, example 7. Let's say we wanted a we needed $2,100 to buy a particular car in 1979. How much money would you have needed in 2003 to buy the same car? Assume that all prices have risen at the same rate as the CPI. Okay, so X is going to represent the year 1979. Y represents the year 2003. So in this case here, the price in dollars for X was 2,100. And then your CPI for X, which represented 1979, here's 1979, that was 72.6. The CPI for Y represents the year 2003, that's going to be 184.0. So that means the price in dollars for Y, which is 2003, that represents the price in dollars for X, which was 1979 times the consumer price index for Y, consumer price index for Y, divided by the consumer price index for X. Just substitute. The consumer price index for X, which is $2,100, that was that price in 1979, times the consumer price index for Y, that's 184.0, divided by the consumer price index for X, that's 72.6. Okay, so using our calculator and rounding to the nearest dollar, $2,100 times 184.0 divided by 72.6. To the nearest dollar, it would be 5322. So that means back in 2003, if I wanted to buy that same car in 2003, I would need $5,322. Okay. And finally, example 8. Suppose admission to a movie cost $9 in 2008. What was its price in 1976 dollars? Assume that all prices have risen at the same rate as the CPI. So we want to find out what was the price in 1976. Well, let's look at what's given to us. This time, Y is going to be 2008, and X is the year 1976. Okay. Let's see, the price in dollars for Y in 2008 was $9. The price in dollars for X is what we're trying to find. We also need the consumer price indices. The consumer price index for X represents the year 1976. That was 56.9. And the consumer price index for Y, which represents 2008, that number is 215.3. And we're still going to use the formula, the price in dollars for Y is equal to the price in dollars for X times the consumer price index for Y divided by the consumer price index for X. Now here's the substitution. The price in Y dollars for 2008, that's $9. That $9 goes here. That's going to be equal to the price in X dollars, in dollars for X. I'll tell you what, I'm going to use a variable instead of writing it out like this. I'm going to let X be that. Or I can do this. To avoid confusion, let P be that price in X, in dollars for X. Let that be P. Times the consumer price index for Y was 215.3 divided by the consumer price index for X, that was 56.9. Now here I have an equation that I'm going to find out what P is. Okay. Now here's what I'm going to do. I'm going to take the reciprocal of 215.3, which is actually 215.3 over 56.9. Its reciprocal is going to be 56.9 over 215.3. I just invert the fraction. So here's what I'm going to do. Take the $9, and it's going to be multiplied by just flipping this over, inverting 56.9 over 215.3. And that's going to be equal to P times this 215.3 over 56.9. That's going to be multiplied by its reciprocal, 56.9 over 215.3. And I'm going to put this in parentheses. You're going to see what's going to happen. The numerator and the denominator of those numbers divide out, leaving me with what P is. And that's going to represent the price in dollars for X for 1976. Using my calculator, I'm going to do 9 times 56.9 divided by 215.3. And I'm going to round this out to the nearest cent as indicated. That means 2 decimal places. So that means I have a 7. The 8 makes that 7 and 8, so it'll be 2.38. So back in 1976, the price of an admission to a movie cost approximately $2.38. Okay. All right, so that does conclude this video on section 3D, dealing with index numbers, the consumer price index, and beyond. Feel free to reach out to me if you have any questions about any of the problems that were presented in this video or any of the homework problems in my math lab.